Hello everyone, good evening.
Good evening, sir.
Good evening.
Good evening, sir.
Everyone, please enable your video.
Good evening, sir.
Good evening. Yes, we were discussing about acids, bases, and salts chapter, right?
Yes, sir.
Okay. So we have already discussed what are acids, what are bases, then reaction of acids with metal, then with metal oxides, metal carbonates, and reaction between acid and base, and that reaction is called neutralization reaction. And neutralization reaction is always exothermic, and the amount of heat or energy liberated during the neutralization reaction is always constant, because it's always a reaction between H plus and OH minus to give water. Yes or no? All that we have discussed, right?
Yes, sir.
Correct. Today we are going to discuss about two different acids, strong acid and weak acids, right? Shall we start? Hello everyone. Yes. Acids are classified into two types, strong acids and weak acids. What are strong acids? What are weak acids? Any idea? Yes.
Strong acids are which have more amount of H plus ions.
Pardon? Strong acids?
Strong acids are which have more amount of H plus ions.
Perfect. So strong acids, they have more H plus ion, in the sense, strong acids, when we dissolve them in water, they completely dissociate into respective ions. Acid means which has the ability to donate H plus, right, in aqueous solution. Correct? ನೀವು ಯಾವಾಗ ಆಸಿಡ್ ನ ವಾಟರ್ ಅಲ್ಲಿ ಹಾಕಿ ಡಿಸಾಲ್ವ್ ಮಾಡ್ತೀರೋ ಆವಾಗ ಆ ಸೊಲ್ಯೂಷನ್ ನಲ್ಲಿ H ಪ್ಲಸ್ ಬಂದ್ರೆ ನೀವು ಡಿಸಾಲ್ವ್ ಮಾಡಿರುವಂತಹ ಸಬ್ಸ್ಟೆನ್ಸ್ ಆಸಿಡ್ ಅಂತ ಅರ್ಥ. If you dissolve any substance in water, if it produces H plus ion or proton, then that substance is called acid. ಹೌದಾ? ಇವಾಗ ಸ್ಟ್ರಾಂಗ್ ಆಸಿಡ್ ಮತ್ತೆ ವೀಕ್ ಆಸಿಡ್ ಗೆ ಏನ್ ಡಿಫರೆನ್ಸ್ ಅಂದ್ರೆ, all strong acids, when you dissolve them in water, they dissociate completely into their respective ions. Say for example HNO3. When you dissolve HNO3 in water, it dissociates into H plus NO3 minus, complete dissociate aಗುತ್ತೆ, so that it can produce more H plus in aqueous solution. Alva? That's the meaning of more H plus ions. More H plus ions ಅಂದ್ರೆ ಜಾಸ್ತಿ H plus ions ಎಲ್ಲಿಂದನೋ ಬರುತ್ತೆ ಅಂತ, ಆಸಿಡ್ ಅಲ್ಲೇ ಇರುತ್ತೆ, but that will be dissociated, completely come out in solution. So when any acid, if it dissociates completely into respective ions, ಅದರಲ್ಲಿ ಒಂದು ion H plus ಇರಲೇಬೇಕಾ? H plus ಇದ್ರೆ H plus ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಕ್ ಆದ್ರೆ ತಾನೇ ಅದನ್ನ ಆಸಿಡ್ ಅಂತ ಕರೀತಾರೆ. Correct? So all the strong acids, they dissociate completely into their respective ions in water or an aqueous solution. They are called strong acids. For example, HCl. HCl is a strong acid. It produces H plus and Cl minus completely. HNO3 is a strong acid that dissociates completely into H plus and NO3 minus. H2SO4 is a strong acid that dissociates into 2H plus SO4 2 minus. In all these cases, we can get H plus ions completely. Whereas weak acids, they do not ionize completely or they do not dissociate completely. Say, for example, acetic acid. Generally, organic acids are weak acids. They do not dissociate completely into their respective ions. Got it? And even carbonic acid. Carbonic acid is also a weak acid. It do not dissociate completely into its respective ions. Hope that's clear. Okay. We take acids. They are classified types. Acids are classified types. One is strong acid. Strong acid. And the other one is weak acid. Weak acid. Okay. Now let us define what are strong acids. Strong acid. What do you mean by strong acids? What do you mean by strong acids? Those acids, strong acids ಅಂದ್ರೆ ಏನು? Those acids which ionize completely in water. Which ionize completely in water. Can you take up some examples? Yes, of course. HCl. When you dissolve HCl in water, it dissociates into H plus and Cl minus. HCl that dissociates completely into H plus and Cl minus. HNO3, nitric acid, that also dissociates completely into H plus NO3 minus. Similarly, H2SO4 that also dissociate completely into H plus and SO4 2 minus. H plus and SO4 2 minus. Now HCl, HNO3, H2SO4. Some more acids are there. Perchloric acid, HClO4. Have you heard about this? HClO4. HClO4. Yes, in the
Yes, sir.
What is that?
Perchloric acid.
Perchloric acid. Perchloric acid is the strongest acid known so far. ಇಲ್ಲಿ ತನಕ ಗೊತ್ತಿರುವಂತ acids ಅಲ್ಲಿ perchloric acid is the strongest acid. Okay. Anyway, okay. HClO4 that dissociates into what? H plus ClO4 minus. Okay. Can you please write down this? ಬರ್ಕೊಂಡ್ರಾ?
Yes, sir.
Everyone should interact with us, then only you can understand. ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ ಇಲ್ವಾ ಅನ್ನೋದು ಗೊತ್ತಾಗತ್ತೆ. ನಮ್ ಜೊತೆ ಇಂಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು, ಸಾಧ್ಯ ಆದಷ್ಟು ವಿಡಿಯೋನ ಎನೇಬಲ್ ಮಾಡಬೇಕು, so that it helps us to interact with you in a better way. Okay.
Okay, sir.
Yeah. So shall I raise this?
Yes, sir.
Fine. Next is weak acids. What are weak acids? Weak acids. Those acids weak acids are nothing but those acids which ionize partially. Which ionize partially in water. Those acids which ionize partially in water are called weak acids. So how can we represent these weak acids? Say for example CH3 COOH. CH3 COOH. If it ionizes partially, then we represent like this. This is also called reversible. If we represent like this, then it indicates it ionizes partially. So when acetic acid is dissolved in water, it ionizes partially into CH3OO minus plus H plus CH3CO minus plus H plus. ಇದನ್ನ ಇನ್ನೊಂದು ತರ ನಾವು ಬರೆಯಬಹುದು. CH3COOH plus H2O CH3O minus plus H3O plus. H plus ಅನ್ನು ನಾವು H3O plus ಅಂತಾನೂ ತೋರಿಸಬಹುದು. That's also called hydronium ion. ನೀವು ಕೇಳಬಹುದು ಸ್ಟ್ರಾಂಗ್ ಆಸಿಡ್ ಅಂತ ಬರೆದಾಗ ಸರ್ you mentioned that H2 on the above the arrow mark HCl ಅಲ್ವಾ, ಅಲ್ಲಿ H plus Cl minus ಅಂತ ಬರೆದಲ್ವಾ, ಅಲ್ಲೂನು you can write like this HCl plus H2O gives H3O plus plus Cl minus, ಅಲ್ಲೂ ಹಾಗೆ ಬರೀಬಹುದು ಆಯ್ತಾ. In both the way we can ಎರಡು ತರ ಬರೆದ್ರು ತಪ್ಪಿಲ್ಲ. Got it? Hope that's clear.
Yes, sir.
Another acid, carbonic acid, H2CO3 plus H2O. This also ionizes partially into H3O plus HCO3 minus. H3O plus HCO3 minus. Finished.
Yes, sir.
Shall I erase this?
Sir.
Yeah. This model, I don't know if you have any doubt. Another doubt idea? Do you have any doubt?
No, sir.
Next we go for indicators. See, most of the reactions, they are taking place in solution. Now, indicator, they mainly help us to find out whether the acidic solution has become neutral or, the solution has changed to basic. We don't know, because sometimes acid solutions are colorless, even basic solutions are also colorless. Then how to identify whether the solution has reached neutralization? Alva? In laboratory, when we are calculating the pH na calculate ಮಾಡ್ತೀವಿ, acidic solution basic solution ಆಯ್ತು ಅಂತ ನೋಡ್ತೀವಿ. ಆ ತರ ಮಾಡ್ಬೇಕಿದ್ರೆ we use a technique called titration. We'll take titration. ಯಾಕೆಂತಂದ್ರೆ ಫಾರ್ಮಾಸ್ಯೂಟಿಕಲ್ ಇಂಡಸ್ಟ್ರಿನಲ್ಲಿ ಇರಬಹುದು ಅಥವಾ ಬೇರೆ ಬೇರೆ ಇಂಡಸ್ಟ್ರಿನಲ್ಲಿ we should ಫುಡ್ ಇಂಡಸ್ಟ್ರಿ ಇರಬಹುದು, ಅಲ್ಲೆಲ್ಲ ನಾವು ಅಸಿಡಿಕ್ ನೇಚರ್, ಬೇಸಿಕ್ ನೇಚರ್ ಅವನ್ನೆಲ್ಲ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಬೇಕಾಗುತ್ತೆ. ಸೊ whenever we are determining basic nature or acidic nature, substance na prepare ಮಾಡಬೇಕಿದ್ರೆ we use a technique called titration. Okay, say for example titration ನಲ್ಲಿ laboratory ನಲ್ಲಿ ಅವನ್ನೆಲ್ಲ ಮಾಡಬೇಕಿದ್ರೆ ಬ್ಯೂರೇಟ್, ಪಿಪೆಟ್ ಅಂತೆಲ್ಲ ಬರುತ್ತೆ. I don't know, I think you might have heard about this burette, pipette. Have you heard about this burette, pipette titration? ಹೇಳಿದಿರಾ?
No.
ಹೇಳಿಲ್ಲ. Okay, so acid base reaction anta ಹೇಳ್ತೀವಲ್ವಾ ನಾವು. So acid base reaction mainly takes place in titration. That's called titration. A titration ನಲ್ಲಿ there will be long elongated tube, that's called burette. A burette ಅಲ್ಲಿ acid na ತಗೋತೀವಿ. That burette is filled with acid, and at the bottom it will have knob. A knob anna ನಾವು turn ಮಾಡಿದ್ರೆ we can run down the acid solution. Okay, and that burette will have markings, volume 1 ml, 2 ml, 3 ml, up to 50 ml. Then we will have conical flask. Conical flask ನೋಡಿದಿರಾ?
Yes, sir.
Lab ಅಲ್ಲಿ ಇರುತ್ತೆ, ಬಟ್ ಏನ್ ಮಾಡೋದು ಸರ್, we haven't been to our school for the last 2 years. School ಗೆ ಹೋಗಿಲ್ಲ. Conical flask, all this something like Greek and Latin. ನೀವು conical flask, burette, pipette, ಇವೆಲ್ಲ ಏನೋ Greek and Latin ವರ್ಡ್ ತರ ಅನ್ಸ್ತಾ ಇದೆ ಸರ್. We really don't know ಅಂತ ಹೇಳ್ತೀರಾ? I know.
Yes, sir.
Fine, but I think in most of even in your textbook, whenever they are giving some activity, they have given that conical flask diagram, image, solution. ನೋಡಿ textbook ಅಲ್ಲಿ ನೋಡಿ ಇದೆ ಅದು. So we'll take conical flask. Conical flask ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ? We will be taking basic solution. Base na ತಗೊಂಡಿರ್ತೀವಿ. Say for example, acid base reaction where HCl ಮತ್ತೆ NaOH ಅಂತಾನೆ ಅನ್ಕೊಳ್ಳೋಣ. Okay, HCl is taken in burette and NaOH solution is taken in conical flask. A conical flask ಅಲ್ಲಿ ತಗೊಂಡಿರ್ತೀವಿ. Conical flask ಅಲ್ಲಿ direct ಆಗಿ how we will prepare NaOH solution. All these are the general informations. Okay, how we will take that NaOH solution. NaOH solution na prepare ಮಾಡೋದಕ್ಕೂ ಒಂದು concentration ಅಂತ ಇರುತ್ತೆ, and those concentrations are expressed like molarity, normality, molality ಅಂತೆಲ್ಲ ಬರುತ್ತೆ. So we will prepare some molar solutions. Our solutions nalla prepare ಮಾಡ್ತೀವಿ. Then out of that some molar solution, some amount we will take NaOH solution. Adanna water ಹಾಕಿ then we will dilute it. Okay, so now in the conical flask we will have NaOH solution. In burette we will have HCl solution. ನಾನು ಹೇಳಿದಲ್ವಾ, burette ಗೆ at the bottom there will be knob to run down the solution, acid solution ನ ಬಿಡೋದಕ್ಕೆ ಅಂತ. So ಆ knob ಅನ್ನ ನಾವು ಸ್ಲೈಟ್ ಆಗಿ ಟಿಲ್ಟ್ ಮಾಡಿದ್ರೆ ಡ್ರಾಪ್ ವೈಸ್ HCl ಬೀಳುತ್ತೆ. ಅದು conical flask ಅಲ್ಲಿ ಬೀಳುತ್ತೆ. ಆವಾಗ ನಾವು conical flask ನ ಈ ತರ ಶೇಕ್ ಮಾಡ್ತೀವಿ. what we will do along with that NaOH solution, we will add a drop of some indicator. Generally, that indicator is phenolphthalein. Phenolphthalein indicator na use ಮಾಡ್ತೀವಿ acid-base titration. That phenolphthalein is pink in color. Pink ಇರುತ್ತೆ basic solution. So ನೀವೇನ್ ಮಾಡ್ತೀರಾ acid ನ drop wise run down ಮಾಡ್ತೀರಾ ಅಲ್ಲಿ pink solution one drop ಬೀಳುತ್ತೆ conical flask ನ shake ಮಾಡ್ತೀರಾ again another drop again you will shake it. So what happens, it is initially it's a dark pink. When you keep on adding HCl solution, I mean acid drop wise, the intensity of the pink color keeps on decreasing. A color fade aagta hogutte. Ultimately it becomes like light pink irutte. The moment you put one drop of acid, it becomes colorless. Oh, now you can say that the solution one which is present in the conical flask is neutral now. Got it? It is neutral. It has formed NaCl solution now completely. So now you can write the reaction HCl plus NaOH gives NaCl plus H2O. Got it? How you will come to know that yes, its pH has reached 7 in ಗೊತ್ತಿರಬಹುದು. Again, we will be discussing that pH scale. If any solution has pH less than 7 is acidic, more than 7 is basic. When it is 7, it is neutral. So yavaga pink color, it is completely colorless, clear solution. Its pH is 7. ನೀವು ಅದನ್ನ ಇನ್ನ ನೀವು ಆಸಿಡ್ ಆಡ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ it become colorless only. But you want to know where exactly it is completely neutral. ಅದಕ್ಕೆ ನೀವು ಏನ್ ಮಾಡ್ತೀರಿ basic solution ಇಂದ ಬರ್ತೀರಿ. In basic solution it is pink in color. ಅದನ್ನ ಆಡ್ ಮಾಡ್ತಾ ಏನಾಗುತ್ತೆ drop wise add ಮಾಡ್ತಾ it becomes colorless. The moment it is colorless, ಆ point ನ note down ಮಾಡ್ಕೋಬೇಕು. There it is neutral. If you keep on adding acid further, it is colorless only, but the solution will be acidic, not neutral, right? Yes or no?
Yes, sir.
Yes, sir.
ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ ನಾನು ಹೇಳೋದು?
Yes, sir.
Yes, sir.
Hello everyone, you are not in your video. Fine. So that is where we need indicator. Phenolphthalein indicator is the general, I mean common indicator used in acid-base titration. I think you might have seen in many movies. ಯಾವ್ದಾರ ಮೂವಿನಲ್ಲಿ ಲ್ಯಾಬ್ ಗಿಬ್ ಎಲ್ಲ ತೋರಿಸ್ಬೇಕು ಅಂತಂದ್ರೆ ಗ್ಲಾಸ್ ಗೀಸ್ ಎಲ್ಲ ಹಾಕೊಂಡು ಏನೋ ಕೋನಿಕಲ್ ಗ್ಲಾಸ್ ಇಟ್ಕೊಂಡು ಈ ತರ ಶೇಕ್ ಮಾಡೋದು. ಇವಾಗಂತೂ ಕೊರೋನಾ ಈ ಟೈಮ್ ಅಲ್ಲಿ ನ್ಯೂಸ್ ಚಾನೆಲ್ ಎಲ್ಲ ನೋಡಿರ್ತೀರ, right? Whenever they are showing the laboratory, they will show that conical flask and shaking like this. That is titration. So there we use indicator to know the change, whether the solution has changed from basic to neutral or neutral to acidic or acidic to neutral. There are different indicators and different types of indicators. Okay, so let us look into the indicators now. How indicators detect change in the pH of the solution, either acidic or basic, basic or acidic, right? One second. Got it? Understood?
Yes, sir.
Yes, sir.
Indicate. Is that visible?
Yes, sir.
Indicator, write down. Indicator is a chemical compound like indicator is a chemical compound Is a chemical compound
Because 17 members are
SSLC, PUC, NTTF ಧಾರವಾಡ ಮತ್ತು ಬೆಳಗಾಂನಲ್ಲಿ ಡಿಪ್ಲೊಮಾ ಮತ್ತು ಸರ್ಟಿಫಿಕೇಶನ್ ಕೋರ್ಸಸ್ 2021 ಅಡ್ಮಿಷನ್ಸ್ ಪ್ರಾರಂಭವಾಗಿದೆ. ಕಾಲ್
indicator which is added to
ಯಾವ ಸಬ್ಜೆಕ್ಟ್ ಹೇಳ್ತಾರೆ?
chemistry.
which is added to the solution. Everyone, please mute yourself. Indicator is a chemical compound which is added to the solution in very small amount. In very small amount to detect acidic or acidic or basic nature. So they ask define indicator. So how do you define indicator? It is a chemical compound which is added to the solution in very small amount to detect its acidic or basic nature. In that, the first one is litmus. First one is litmus. ಹೇಳಿದಿರಾ ಲಿಟ್ಮಸ್? ಹೇಳಿದಿರಲ್ವಾ ನಾವು?
Yes, sir.
ಏನ್ ಮಾಡುತ್ತೆ ಲಿಟ್ಮಸ್?
Changes the color.
ಯಾವ ಕಲರ್ ನ ಚೇಂಜ್ ಮಾಡುತ್ತೆ? ಆಸಿಡ್. There are two different colors in case of litmus, blue litmus and red litmus, right?
Yes, sir.
So how color is changed when we take acid? How
Red.
that acid changes the
Blue to red.
Pardon?
Sir, when litmus is added to acidic medium, it changes from blue to red.
Correct. So in acid changes blue to red. Blue litmus to red litmus. So acid changes blue litmus to red litmus. Suppose if you take base, that changes.
Red to blue.
Correct. So base that changes red litmus to blue litmus. Base that changes red litmus to blue litmus. Similarly, another indicator. Another indicator. Red cabbage juice. Have you heard about this? Red cabbage juice. Have you heard about this? Get it, huh? This also can be used as indicator. Red cabbage juice. As the name of the cabbage is actually purple in color. If you take an acid, see, actually red cabbage juice is purple in color in neutral medium. Okay, it is purple in color in neutral medium. So if you add acid and if the solution becomes acidic, then it becomes pink, purple to pink. So acid that changes purple to pink.
In base, it turns green now, sir.
Absolutely fantastic, very good. In base, changes purple to green. The line is so everyone. Shall I erase this?
Yes, sir.
Yes, sir.
Next, turmeric juice. This also can be used as an indicator. Turmeric juice. Turmeric juice. In acidic medium, if the solution is acid, see turmeric juice basically yellow in color in neutral medium. Yellow in neutral medium.
Sir, in acid, turmeric will remain yellow in color only, sir.
Exactly. Very good. So in acidic solution remains yellow. It
In
remains
base, turns reddish brown now, sir.
reddish brown or deep brown. Both are correct. In the basic medium, in basic, it becomes reddish brown. reddish brown or next is phenolphthalein. Phenolphthalein. Is that visible? Phenolphthalein. Actually, phenolphthalein is colorless. Phenolphthalein is colorless. So, acidic phenolphthalein ಬಗ್ಗೆ ಕೇಳಿದಿರಾ?
Yes, sir.
Okay, in acidic solution, what is the color? Phenolphthalein.
Colorless.
It is colorless.
Yes. In acidic medium is still colorless. That is what I told, right? When we take acid in purate and basic base in conical flask, and you will add 1 or 2 drops of phenolphthalein to the conical flask, it becomes pink in color, and you keep on adding acidic solution dropwise, right? And you will shake the conical flask. That pink color, it loses its intensity. Its color becomes fade. So at one point of time, it is very dull pink. The moment you add 1 drop of acid, it becomes colorless. That means the solution is absolutely neutral now. If you keep on adding acidic solution, color of the solution in the conical flask won't change. Reason is the indicator phenolphthalein, it is still colorless even in acidic solution and neutral medium. When that neutral point has reached, that is what you want to know. That is why you have to add dropwise acid in titration. That's called titration, correct? So in acid, it is colorless. In basic solution, it is pink in color. In basic solution, it's pink in color. Shall I erase this?
Yes,
Yes,
sir.
sir.
One more indicator. Have you heard about methyl orange? ಕೇಳಿದಿರಾ? Hello. Am I audible?
Yes, sir.
Methyl orange. Have you heard about methyl orange?
Yes, sir.
Okay, how it changes the color of methyl orange? How many indicators are done? 4. The next one is 5, right?
Yes, sir.
Methyl orange. Methyl orange. This methyl orange is orange in color in neutral medium. Orange color in neutral medium. So in acidic solution, acid,
Then it turns into red color.
so in acid, color changes from orange to red, right?
Yes,
Yes,
sir.
sir.
In acid, color changes from orange to red. And in basic medium,
It turns yellow.
yes. In basic medium, orange color changes to yellow. In basic medium, color changes from orange to yellow. Next, there is one more type of indicators. Olfactory indicators. Have you heard about this?
Yes, sir. By using the smell, by seeing the smell there.
Correct. Olfactory indicators ಅಂತಂದ್ರೆ ಸ್ಮೆಲ್ ನೋಡೋದ್ರ ಮುಖಾಂತರ ನಾವು ಇದು ಅಸಿಡಿಕ್ ಬೇಸಿಕ್ ಅಂತ ಹೇಳ್ಬೋದು. Olfactory indicators. Can you write down olfactory?
Sir, examples are onion, no sir?
Yes, onion cloud strip. Ammonia ಸ್ಮೆಲ್ ಹೇಗಿರುತ್ತೆ ಅಂತ ಗೊತ್ತಾ?
No sir.
ಆನಿಯನ್ ಸ್ಮೆಲ್ ಹೇಗಿರುತ್ತೆ ಅಂತ ಗೊತ್ತಾ?
Yes,
Yes,
sir.
sir.
ಅದೇ ammonia smell. See, onion has got a characteristic ammonical smell. Okay. If the solution is acidic, that ammonical smell retain. ಅಂದ್ರೆ ಅದು acidic solution ಇದೆ ಅಂತಂದ್ರೆ ಆ ammonical smell ಹಾಗೆ ಇರುತ್ತೆ. ಅದೇ ಬೇಸಿಕ್ ಅಂತಿದ್ದಾಗ ಆ ammonical solution ಇರಲ್ಲ. ಅದಕ್ಕೆ ನೋಡಿ ಈರುಳ್ಳಿನ ಕಟ್ ಮಾಡಬೇಕಿದ್ರೆ I don't know whether you have seen this or not. ಈ ಕಾಂಟ್ರಾಕ್ಟ್ ತಗೋತಾರಲ್ಲ ದೊಡ್ಡ ಅಡಿಗೆ ಮಾಡೋರು ಅವ್ರೇನ್ ಮಾಡ್ತಾರೆ ಆನಿಯನ್ both the ends they'll cut the onion, they peel that outer layer, then put it in water. Correct?
Yes, sir.
Yes, sir.
ಯಾಕೆ ವಾಟರ್ ಅಲ್ಲಿ ಹಾಕಿರ್ತಾರೆ ಅದನ್ನ?
Water is neutral.
Water is neutral, right? So somewhat that water absorbs that ammonical smell, nothing but it decreases its acidic nature. If onion smell comes, that ammonical smell, if that a characteristic smell is still retained in that onion, means it is still somewhat acidic. ಅದಕ್ಕೇನೆ ಅದೇನಾಗತ್ತೆ, ನೀವು ಈರುಳ್ಳಿ ಕಟ್ ಮಾಡ್ಬೇಕಿದ್ರೆ ಕಣ್ಣಲ್ಲಿ ನೀರು ಬರುತ್ತಲ್ಲ, ಅಯ್ಯೋ ಗೊಳೋ ಅಂತ ಅಳ್ತೀರಾ. ಯಾಕೆ? Because it has got that sulfur content. Onion, acidic nature. So it sends some irritation on eye. That is why ಏನಾಗುತ್ತೆ, ಕಣ್ಣಲ್ಲಿ ನೀರು ಬರುತ್ತೆ. ಅದೇ ನೀವು ಆಫ್ಟರ್ ಪೀಲಿಂಗ್ ದಟ್ ಆನಿಯನ್ ಔಟರ್ ಲೇಯರ್ಸ್ ಬೈ ಕಟಿಂಗ್ ಇಟ್ ಬೋತ್ ಎಂಡ್, ನೀವು ಕಟ್ ಮಾಡಿ ಅದನ್ನ ನೀರಲ್ಲಿ ಹಾಕ್ಬೇಕು. ಯಾಕೆಂತಂದ್ರೆ ಕಟ್ ಮಾಡಿಲ್ಲ ಅಂತಂದ್ರೆ ದಟ್ ಅಮೋನಿಕಲ್ ಸ್ಮೆಲ್ won't go, it won't destroy. Having said that, water ಅಲ್ಲಿ ನೀವು ಆನಿಯನ್ ನ ಕಟ್ ಮಾಡಿ ಇಟ್ರೂನು that completely that ammonical smell won't go. Reason is water is not basic, water is neutral, right? Yes or no?
Yes, sir.
ಇನ್ನು ನೀವು ಕೆಲವೊಂದು ಕಡೆ ಮಾಡ್ತಾರೆ, ಯಾಕೆಂದ್ರೆ it's all depends on the facility, right? In sometimes what they'll do, after peeling that outer layer of the onion and cutting it on the two ends, they'll put those onions in water and they'll add little amount of baking soda. Have you seen that? Have you seen that baking soda? What is baking soda? It's a base. Baking soda is base. So when you add baking soda to water, that solution becomes basic. Our basic solution that ammonical smell is completely destroyed. Got it? Since that ammonical smell is completely destroyed, ಏನು ಆಗಲ್ಲಪ್ಪ, ಎಲ್ಲಾ ಕಡೆ ನೋಡ್ಕೊಂಡು ಈರುಳ್ಳಿನೇ ನೋಡ್ಕೊಂಡು ಕಟ್ ಮಾಡಿದ್ರು ಕಣ್ಣಲ್ಲಿ ನೀರು ಬರಲ್ಲ. ಯಾಕೆ? there is no ammonical smell. Ammonical smell ಇದೆ ಅಂತಂದ್ರೆ ಅದ್ರ ವೇಪರ್ಸ್ ಇದೆ ಅಂತ ಅರ್ಥ. ಹೌದಾ? ಆ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅದ್ರ ವೇಪರ್ಸ್ ಎಲ್ಲ ಈಚೆ ಬರೆದ್ರೆ ನಿಮ್ಗೆ ಸ್ಮೆಲ್ ಹೇಗೆ ಬರುತ್ತೆ? ಬರಲ್ಲ. ಅಲ್ಲಿ ಸ್ಮೆಲ್ ಬರ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಅದ್ರ ವೇಪರ್ಸ್ ಬರ್ತಾ ಇದೆ ಅಂತ ಅರ್ಥ ತಾನೆ.
Yes, sir.
ದಟ್ ಈಸ್ ವೈ. ಸೊ ನೀವು ಅಡಿಗೆ ಮನೇಲಿ ನೋಡಿರ್ಬೋದು, ತುಂಬಾ ದೊಡ್ಡ ದೊಡ್ಡ ಫಂಕ್ಷನ್ ಅಲ್ಲಿ ಆ ಈರುಳ್ಳಿನ ಕಟ್ ಮಾಡಿ ನೀರಿಗೆ ಹಾಕಿ ದೆನ್ ದಿಲ್ ಆಡ್ ಲಿಟಲ್ ಅಮೌಂಟ್ ಆಫ್ ಬೇಕಿಂಗ್ ಸೋಡಾ. ಸೊ ದಟ್ ಏನಾಗುತ್ತೆ, ಆ ನೀರು ಬೇಕಿಂಗ್ ಸೋಡಾನ ಆಡ್ ಮಾಡಿದ ತಕ್ಷಣ ಇಟ್ ಬಿಕಮ್ ಸ್ಲೈಟ್ಲಿ ಇಟ್ ಬಿಕಮ್ಸ್ ಬೇಸಿಕ್. ಸೊ ಬೇಸಿಕ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಆನಿಯನ್ ಇದ್ರದ್ದು ಅಮೋನಿಕಲ್ ಸ್ಮೆಲ್ ಇರಲ್ಲ, ಹೋಗ್ಬಿಡತ್ತೆ ಆಚೆ. ದೆನ್ ಈಸಿಲಿ ವಿ ಕ್ಯಾನ್ ಕಟ್ ದಿ ಆನಿಯನ್. Fine. All factors indicators giving different odor. Smell and chemical termally we call as odor. Okay. Indicators giving different odor in acidic and basic solution. Indicators giving different odor in acidic and basic solution are called olfactory indicators. ಅದೇ ರೀತಿ vanilla, you can write down onion cloves and vanilla essence. Vanilla has got sweet smell. Ice cream alla tindirbekkalla, vanilla ice cream. That vanilla smell retains even in acidic medium, but in basic medium it destroys. Shall I erase this?
Yes, sir.
Yes. Olfactory indicators. There you can write onion clove strips, onion clove, in acidic medium, ammonical smell. In basic medium, ammonical smell destroyed. Ammonical smell iralla, ammonical smell destroyed. The next is vanilla essence. So in acidic medium, characteristic sweet smell. Characteristic sweet smell. In taste, again characteristic sweet smell destroyed. Characteristic sweet smell destroyed. Got it? See, that's all about the acids. So what are acids and what is their nature? Then reactions of acids with different compounds, like reactions of acids with base, reactions of acids with metal, metal oxide, metal carbonates, all that we discussed, right?
Yes, sir.
What happens when acid reacts with metal? Liberates hydrogen gas, and that too with the reactive metals. Remember, in the first chapter, I gave you some series, reactivity series, right?
Yes,
The
sir.
elements which
Yes,
are
sir.
present above hydrogen, they are able to liberate hydrogen gas when they are treated with acid. Below hydrogen won't give. Say, for example, copper, silver, they won't liberate hydrogen gas when they treated with acid. ಹೌದಾ ನೆನಪಿದ್ಯಾವೆಲ್ಲ?
Yes, sir.
Yes, sir.
Okay. So next class we'll start with bases. Okay. Got it?
Yes, sir.
Okay, guys. Thank you.